Given f of x is equal to the square root of x minus 2 and g of x is equal to x minus 4 over 5, we want to find f circle g and then the domain, and we want to find g circle f and its domain. So let's start with the first one. F circle g of x. So f is the outside function, g is the inside function. So this is f of g of x. Start with the inside function, g of x. And g of x is x minus 4 over 5. So we have f of x minus 4 over 5. So this means that wherever we see x in the f function, we put in x minus 4 over 5. So we have square root of x minus 4 over 5 minus 2. Let's get the domain. So there are 3 steps to it. The first one is the domain of the inside function, g of x. And here, g of x is x minus 4 over 5. So here we have fraction. So the denominator cannot equal to 0. So this is true. 5 is not equal to 0. So this here, the domain is all real numbers. The second step is the domain of f of g of x, which is what we found. The square root of x minus 4 over 5 minus 2. So here we have fraction and we have the square root. So fraction, the denominator, which is 5, cannot equal to 0. This is a true statement. Because it's true, we don't worry about it. No exclusion there. And then we have the square root. Inside the square root, x minus 4 over 5 minus 2 need to be greater than or equal to 0. So here we need to add the 2 over. So x minus 4 over 5 is greater than or equal to 2. The 5 multiplied over x minus 4 is greater than or equal to 10. Add 4 over. So x is greater than or equal to 14. The third step, get the domain that we want, the answer. The domain of f circle g, the combination of the first 2 steps. The first step, the domain is all real, so no restriction. The second step, the first one here is true, so no restriction. And then we have x need to be greater than or equal to 14, so we have a restriction here. So draw ourselves a number line. We have the number 14. X need to be greater than 14, so the arrow is heading toward the right. So x is greater than or equal to 14. So there's an equal sign to it. So this is a bracket. So our domain is bracket 14 to infinity, parentheses. Let's get the second problem, which is g circle f. So g circle f of x. So g is the outside function, f is the inside function. So this is g of f of x. So start with the inside function, f of x, which is the square root of x minus 2. So we have g of the square root of x minus 2. This means that wherever we see the x in the chi function, we put in the square root of x minus 2. So we have the square root of x minus 2 minus 4 over 5. Let's get the domain. So the first step is the domain of the inside function. And the inside function is f of x. So we have f of x, which is the square root of x minus 2. So here we have square root. So inside the square root, which is x minus 2, needs to be greater than or equal to 0. Add 2 over. So x is greater than or equal to 2. The second step is the domain of chi of f of x. The one that we found. The square root of x minus 2 minus 4 over 5. So here we have fraction. The denominator 5 cannot equal to 0, but this is true. So here there's no restriction here. The second one we have is the square root. So inside the square root needs to be greater than or equal to 0. So add 2 over. So x is greater than or equal to 2. So let's get our final domain, the domain of chi circle f. The first step, the domain we have a restriction that x needs to be greater than or equal to 2. The second step, the first one is true, so no restriction. The second one, x needs to be greater than or equal to 2. So here, the first step and the second step both have the restriction that x needs to be greater than or equal to 2. So draw ourselves a number line with the 2. X needs to be greater than or equal to 2. So the arrow is heading toward the right. There is an equal sign, so we have the bracket. So this is bracket 2 to infinity.